In this video, I'm going to introduce Chomsky Normal Form and the algorithm to take a tree in a context-free grammar and convert it to a binary branching tree. And this is the objective that Chomsky Normal Form achieves. So we can take something like 0, lambda 0, which is ternary branching at the top, and convert it into binary branching structures that look much more like the syntax we're used to seeing in linguistics. So we say that a CFG is in Chomsky normal form if all rules are of the form of the following. A goes to BC, where these are non-terminals, so these are variables, or A goes to A, which is a terminal node. Of course, we're also allowed to have S goes to lambda in this case, because lambda is a terminal node and it just means the empty string. We also have to have that B and C cannot be the start variable, so we can never have a rule that takes us back to the start variable. Let's look at the system we're going to work with in this video. So our system here is a little bit more complicated than the one I introduced in the previous video. First, we have S goes to ASB. So this is a problem for Chomsky normal form because 1, there's a ternary branching structure, but 2, S is a start variable and S takes us back to the start variable. So that's not going to be okay for our system. We also have A going to AAB, A or lambda, so A is our only terminating symbol here. That goes to the empty string. And then of course B goes to ABA, S or BB. The string that we're going to convert into Chomsky normal form is ABBA, or ABBA. Here we can see we need a ternary branching structure from S. Then we need another ternary branching structure from B, and we're going to eliminate that. So let's introduce the algorithm, and the algorithm is pretty complex. There are a lot of steps, so I highly recommend you write these along and pause the video, take a look at what I've done, take a look at what you've done, and make sure we match up. So we'll do the procedure with an example. The first thing we're going to do is we're going to add a new start variable S0 and send the new start variable to the old start variable. So there's just one thing we do here. S is our old start variable, so let's add a new rule. S0 goes to S. And now we've taken care of the start variable problem because now none of our rules send us back to the start variable because we've introduced a new one. So before we had issues here with ASB and with B going to S, those issues are now gone. So that's our first step, add a new start variable and send our new start variable to our old start variable. The second step is to remove all rules where we have a variable going to the empty string lambda. So in this case, we want to remove just A going to lambda here. So we're going to remove that rule. And we're going to keep in mind that we have removed A goes to lambda. So that's no longer a thing in our system. So then the third step requires that we remember that we removed A goes to lambda. And we say that for each variable to lambda rule removed, if we have another rule that sends B to some terminals or non-terminals with that R in it, we're going to add a rule where R is removed. So let's think about this in terms of our example here. So we removed A goes to lambda. This means that when we have the other rules, so let's take a look at S goes to ASB, we're going to add another rule where this A has essentially become lambda. So we're going to add the rule S goes to SB. In other words, there is an invisible lambda here that we're not including. So this is how we deal with getting rid of that lambda. So if we take a look at our example on the left, we have S goes to ASB. So we're going to add the rule where we have just SB here because we removed A goes to lambda. So we've created a rule where this A does not exist. We still keep the old rule, of course, but we just add a new rule where the A doesn't exist. For A goes to AAB, we will do another one. We'll pretend that this A has gone to lambda and we'll add a rule without it. So then we have terminal A with variable B. Then for this third rule, b goes to capital A, b, capital A, we have to take a look at the second point. If b goes to u, r, v, r, y, we add all possible combinations of that r being removed. So we have to add all possible combinations of these a's being removed. So we have one scenario where just the first a has gone to lambda, and we're left with b variable a. The other scenario is where the second a has gone to lambda, so we're left with variable a and then terminal b. Then the final scenario is if both of them become lambda and are deleted, and then we're just left with b. So for each r to lambda rule we remove, we have to repeat this process. I've only had one in here, so we only have to do it once, but if we had, say, b goes to lambda, we'd have to do it again for all of our b's. Okay, so these are the rules we have added. We've added s goes to sb because this a has become a lambda. We've added a goes to ab because this a has become a lambda, and then I just explained the b rules. Step 4. We're now going to remove all unit rules, and so of the form r goes to t, and we're going to add r goes to some string w for every t goes to some string w rule. We only have one that we have to deal with, and that is s0 goes to s. So what do I mean by this? I mean that we remove this s rule, so instead of having s, we copy everything that was in s and rewrite it under s0. So instead of just going to one thing s, we're essentially rewriting everything that s goes to, kind of like transitivity. So we'll end up with ASB or B or SB under S. So think of it like transitivity. If A goes to B and B goes to C, we're essentially removing B and just doing a straightforward line directly from A to C. And that's the process this goes through. In fact, we actually see another one here. We have B just going to S. So we're going to remove S here, and we're going to rewrite everything under S under B as well. So we will have B going to ASB, B going to B, and B going to SB as well. And this is just like we did with S0. So again, we're just doing transitivity again. Instead of B going to S and S going to a bunch of things, we're just going to send B straight to that bunch of things. So that's step number 4. And we're not done yet. Oh boy, oh no, we aren't. Step number 5. We've done kind of the tedious task. And now we're just going to take all of our ternary branching structures and make them binary branching. So if we have R going to U1, U2, U3, blah, 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 these are terminals or non-terminals, we're going to convert those to R goes to U1, U1, where we have a first terminal or non-terminal, and then we have a variable that contains the rest. So what do I mean by this? Well, here I have S0 goes to ASB. So I want to keep A, but I want to convert this SB into something else. Let's call this U1. So we're going to delete this rule, S goes to ASB, and we're going to replace it with S goes to A and U1. But then we're going to add a new rule, U1, that goes to whatever we've deleted SB. So essentially now, instead of getting a structure that is ASB, we now have a binary branching structure AU1, that U1 now goes to SB. So we're making this conversion here. And this is for all rules that have more than 2 terminals. Okay, so let's continue and finish off the rest of the rules here. Now what we can do if we want is we can convert this SB just to U1, but I won't do that. For S, well, we have ASB again, so we can remove that and we can add our AU1 rule. We already have U1 going to SB, so we don't need to define it again. For A goes to terminal A, then variables AB. Well, we want to keep the A, but we want to convert this AB into another variable. So we're going to remove this and we're going to call this AU2, and then U2 will become variables AB. So again, we're just converting this structure terminal A, variables A, B, into a structure that is binary branching with U2. So here's a nice demonstration of what it becomes. Okay, now for B, we have a few of these we have to do. So the first thing, we have capital A, lowercase b, capital A. We'll remove that. We'll replace that with A, U3. And U3 is going to be the last two variables here. So B and A. Then, okay, BB is 2, BA is 2, AB is 2, B is 2. Oh, we have an ASB here. We already have something for this. So we already know that ASB is the same thing as AU1. So now we've taken care of all of our rules that have more than two variables, or terminals or non-terminals. Okay, finally, the last step. We're going to convert all terminals to non-terminals. This might sound a little bit crazy, but essentially we want all of our forms to be in variables for binary branches and terminals for unary branches. So this B, we don't want a terminal B here. We want just a non-terminal. So actually what I could do is I could take a look at just the binary branching ones. So for instance, this AU2, we don't want a terminal and a non-terminal. We want to redefine this one as something like V1U2 and then add a rule where V1 goes to A. So we can get rid of this. A is fine because it is a terminal, but this AB is not okay. Instead, we want this AB to be V1B, so that way we have two variables. Okay, B goes to AU3 is fine. This BB is not good because we have two terminals here. We want this to be two variables. So we're going to introduce V2, V2, and send V2 to B. Okay, similarly with this BA, we don't want BA here. This could be V2A instead. I'll have to move these over a little bit. Okay. We have capital A, lowercase b, so we have a terminal there with a variable. That's not good, so we'll call this A, V2, then V2 goes to B. B is fine because it's a terminal on its own. AU1 is fine, and SB are fine because they're both variables. KU1, SB is fine, AB is fine, but here we have another issue because we have a terminal and a variable mixed together, so we want to get rid of that and replace that with V2A. So now all of our rules are of these forms. We have A going to BC, or we have A going to a terminal. And now we can say that it is in Chomsky normal form, because it's either one of these two forms. Okay, so now we're done. Here is our final list of rules. I have not done this entirely correctly. I need to make some substitutions here just to make it consistent. And now it is consistent. So as you can see, the terminals, which I've written in light blue, and the variables are in red. And we can convert our string ABBA that we've seen before into a binary branching structure. This is not necessarily the same as I had it before, so we got rid of this V2. So this is just ternary branching, we got rid of this V1. This is just unary branching. But now we have a nice binary branching structure that either sends a variable to two variables or a variable to a terminal. So that is Chomsky normal form. If you would like more practice questions, you can just make up the rules yourselves and you can try to convert it. You can run it through programs online. I'll try to find one and link it in the description below. But these problems do take a while. They take quite a bit of time, and if you make one mistake, you could pretty much screw yourself up very quickly, and it can be very hard to recover. So take in mind all the steps very carefully. If you need more clarification, please ask in the comments below, and I'll answer them the best that I can.